Hello guys, welcome back. So in this particular session, we'll solve two different numerical, which cover the progression waves concept, and it's easy. So let's just dig in. So the first question is: the progressive wave travel on a stretched string. A particle on a string takes 4 milliseconds. See, it takes 4 milliseconds to move from its mean position, mean position to from its mean position to one of its extreme position. Okay, so what I can do, I can just simply draw this actually. So let's suppose this is the behavior of the string. Assume karo, ठीक है. Now started from somewhere here. Now this is the maximum amplitude point. Okay, now what he's saying is that string takes 4 seconds to move from its mean position to one of its extreme position. मतलब यहाँ से लेके ये मीन पोजीशन है, करेक्ट. मैक्सिमम एम्पलीट्यूड उसको कवर करने में, इतना पार्ट कवर करने में उसको लगता है 4 मिली सेकेंड. ठीक है. सो ऑब्वियसली okay, we'll discuss this then. Mean position of its extreme position, the distance between two consecutive points on the string which are at their mean positions is 2 centimeter. So they are saying, talking about this distance, okay? The distance between the two consecutive points on the string which are at their mean positions is 2 centimeter. So if I just try to make see what is this point. So let's suppose this one is this one. So I'm taking this consideration कि ये दोनों पॉइंट है कंसेक्यूटिव पॉइंट्स है मीन पोजीशन के. कंसेक्यूटिव ये दोनों भी ले सकते हो, ठीक है, कोई भी ले सकते हो. जस्ट टू सेपरेट इट फ्रॉम द प्रीवियस केस आई एम जस्ट डूइंग इट हियर. So this is 2.0 centimeter. Okay, now with these two information, can we find the frequency, wavelength and the speed of the wave? So to calculate the frequency I need time, right? Because n is equal to basically 1 by time. So n is equal to 1 by total time period. Now what is this time period? Time period is to complete an entire wavelength. Now we have just seen here that to cover from here to here it takes 4 seconds. So it will take another 4 seconds to cover here to here, then another 4 seconds to here, then another 4 seconds to here. So how many seconds is basically take? 4 plus 4 plus 4 plus 4. So basically this is happening 4 times. So total 4 times of 4 seconds. So basic understanding is 16 second it takes to 16 millisecond. Okay, 16 millisecond it takes to finish one entire cycle. So this is when it complete entire one cycle, we call so one time period, right? So it takes basically 1 by 16 milliseconds. So I can just write 10 to minus 3 here. Okay, so what is the hertz actually? Okay, so it is n raised to 10 raised to 3 divided by 16. If you just calculate it, you should get 60 plus plus or minus something, some error. Okay, hertz, that can be plus or minus 2 3 5. Okay, so just do the quick calculation. Now let's move further. Now I want to calculate, the first thing is done, frequency. Yeah, now we want to find wavelength. So what is wavelength basically? So wavelength is nothing but how many what is the distance. So as we see here in here, the two consecutive point has 2 point centimeter distance, isn't it? Then what is from here to here? This is entire wavelength, correct? So it's a 2 plus 2. So from the question itself we can see this is actually very easy question. So it's a 4 centimeter. So lambda is equal to 0.04 meter, you can write that way. Okay, now I want to find the velocity. Velocity is what? Distance by time, and time is what here? N. So we already have all the information, right? Just multiply. So if you do that, then you should get 2.5 millisecond meter per second. Okay, that's the answer. So please do this calculation. Let me go with the further question. Now find the distance between two successive nodes in stationary wave on a string vibrating with frequency of 64 Hz. So distance between two successive nodes, that's what I have to calculate, right? Distance between two successive nodes. So just write the given data in that case. Okay, so what is the given data we have here? So if I have find the distance between two successive nodes in the station. So you should know actually what you're talking about. Just draw like this. So this is one nodal point, this is one nodal point, this is one nodal point. Okay, they are asking what is the distance between two nodal point. So generally if this is the wavelength, okay, lambda, then what is this? Lambda by 2. Just keep this in the mind when you do the numerical, that's all. Okay, now frequency of with the vibrating string is vibrating with a frequency of 64 hertz. So what is the frequency? N is equal to 64 hertz. The velocity of the progressive wave that resulted in the stationary wave is 48 meter per second. Now I think from the previous numerical it was quite clear that v is equal to n lambda. So what is a lambda? Then v by n. So v is equal to what? 48 divided by 64. So if you just do this, then you should get 0.75 meter. Okay, but remember this is not the answer they are looking for. They are looking for this answer. This is the trick here. They are asking the distance between two successive points. So the answer is lambda by 2 is equal to 0.75 by 2, so 0.3 something, 0.375 meter. Okay, so this is the final answer. So be very careful when you do this kind of numerical. Okay, I feel that now you can easily attempt similar kind of numerical based on this concept. So in the next video we will see different kind of numericals.